Well, welcome back. So we continue our discussion on this particular topic of wind energy. We have gone through all these kind of fundamentals of the fluid mechanics. Initially, we looked at the renewable energy, the status, and um, all this stuff. Now, slowly, with that kind of knowledge, now we'll move to the discussion or the detailed discussion of wind energy. So, to continue with that discussion, what we'll do first, we'll try to look at some of the fundamentals of wind, and the brief history of wind turbines, and then we'll move to the different wind turbine technologies, and then slowly we'll move on the discussion of aerodynamics and things like that. Okay. So what we are going to do today is that basically we look at different wind energy and turbines, and that's kind of things. So to do wind energy, the important thing to know is that what is wind. Okay. And obviously the questions that arises that what is wind, how is wind generated. So these are some pertinent questions that one has to kind of answer before moving to the. So in one hand, you can say that wind is air in motion. That means the air that we have, which is already in motion. So wind is the also result of conversion of the potential energy of the atmosphere into kinetic energy due to some pressure differential. Most prominent feature of climatology in India is the monsoon circulation. So obviously one can, but one hand you can kind of, so primarily if you look at the major source of this wind, which is air in motion, or one can say the original source is essentially on this earth is the sun. So why? Because this is the primary source of all this. Because the sun heating happens at the earth's surface, and due to uneven heating of the earth's surface and the rotation the wind produces. So if you see this complete picture here, you can see the different circulations. Obviously the red one is marked as an warm current, the other one is the cold current. So what you have that this uneven heating is also associated, this global winds that we just talked about is kind of caused by the pressure difference across the earth's surface due to this uneven heating of the earth by solar radiation. For example, if somebody wants to look at little bit in more detail, the amount of solar radiation which is absorbed at the earth's surface is always higher, or rather one can say is that greater at the equator than the poles. So these are the poles, so it will be always higher at equator. What this does, so one can always see that you have more heating along this, you have poles are not getting heated that much. So the variation in the incoming energy, the difference or this variation sets up the convective cells in the lower layers of the atmosphere, which is that's called the troposphere. I mean, or in a simple model, one can think that the air rises at the equator and sinks at the poles, because this equator is getting heated up more compared to these poles. So air rises at the equator and sinks at the pole. And that's why this circulation of the atmosphere that results from this uneven heating of this Earth surface is also influenced by the rotation. So rotation is another key factor. The obviously heating and the rotation. Okay. So on top of that, you have this seasonal variation, which is different time of the year. One can see the different variation. So all this gives rise to this variation in the circulation. So in a nutshell, the spatial variation in heat transfer to this Earth atmosphere create the variation in atmospheric pressure field, which causes air to move from high to low pressure. So air moves from high pressure to low pressure. So what one can see, there is a pressure gradient which kind of gets established in the vertical direction, but obviously it can have a effect due to this gravitational force and other things. So that's how these circulations are going to impact this wind's motion and all these things, or rather getting the wind is created. Now, this is where the importance of the wind energy comes to the picture, because you can understand that heating of Earth's surface is a natural process. Rotation of the Earth's surface is also a quite natural process. And other things that is happening, and obviously seawater level, plate movements and all these things. So obviously, primarily this heating in rotations that creates this pressure differential, which is going to cause this motion of the wind. And wind has quite a bit of energy. So typically the kinetic energy of the wind is quite high. So here, that's the idea of this renewable energy production method or approach using this or wind energy here. So whole idea is that wind is treated like a fuel, and this energy content of the wind that can be transformed for getting electricity and other things. So to do that, you have some requirement of the land area. Okay. I mean, typically it's the 1% of the land area which is needed to have this kind of installation of the wind energy. So if I put this information in that way, it just like I have an alternative fuel source, which is wind, so that one can use to extract or harness energy. Now, if we go back a little bit of the history, this wind energy started long back when this was used for different purposes. And this picture is a nice picture. Most likely these are coming from Europe, and if not wrong, in Netherlands, where wind energy was used for mills, and that's what they call it, a windmill, because these are the configuration of the turbine, but the energy that you extract out using that you use for cutting of the woods and things like that. But yes, starting of wind energy is all this, the whole development happened. So we can see that how these things progress. So as I said, that harnessing energy from wind power or wind is not something absolutely a new idea. Okay, it was used earlier, but with the more and more demand towards the non-renewable energy sources, this has gained quite a bit of popularity, or this has gained a lot of popularity, and people have been emphasizing a lot different countries so that whoever has wind availability or wind potential where the turbines can be installed to extract out the energy from the. If you look at the first wind energy system, which was in the ancient civilization in the Persia, so it was vertical axis windmill. So it's sail connected to a vertical shaft, which is grinding stone for milling. And so this is what you can see on the ancient age. Now, similarly in the Middle Age, so it was introduced in the North Europe, where the horizontal axis windmills. So these are what I said, the horizontal axis windmills, because due to the motion of the wind, this whatever energy you get, that translate into some motion to cut wood and all these things. Then 19th century in US, where you have water pumping using windmills in the America. So where 1988, first large size wind electricity generation turbine, which is 17 meter in diameter, the generating power of 12 kilowatt was introduced. Okay. Then 1819, Lewis Electric Company of New York sell generator to retrofit onto existing windmills. So then 20 to 1950, propeller type 2 blade, 3 blade. So that's how you can see the, and then Europe leads to decline in WECS. Okay. So that is how the progress was happening. Okay. Now, modern era, if you look at it, so if you see some nice, beautiful installation in some of the Europe, you can see these are the offshore wind turbine installations. Obviously, we'll talk about this more when you move on. So these are offshores. So what has happened is that scale increase happened, commercialization happened, competitiveness took place, grid integration. So now we have three blade horizontal axis wind turbine. And if you see this picture with the size, how it is increasing, obviously that has also increased the power producing capacity. Okay. The one which here it is a 6 megawatt in a real turbine. So we have already talked about that more and more swept area is increases because the wind power is area into velocity q. So one is that if we can increase the area, so that's what it is happening here, increasing area, that is increasing power, but also the velocity if you increase. But more you increase the size, it's going to increase. I mean, more you try to generate power by increasing the size, obviously the size of the turbine is going to be. So, so this is how in a cartoon you can think about wind physics basic, that it's more like an. So if we put them together, so what we have atmospheric air in motion, that is what is wind. Energy source is the solar radiation, primarily absorbed by different earth surface, converted through convective processes due to this temperature difference to generate this motion. So we have spatial scale, planetary scale, the global circulation, synoptic scale, weather system, mesoscale, local topographic and thermally induced circulation, microscale, urban topology. Now, that's how you can have different type of wind, and you can also think about different types of wind energy. So if we look at the planetary circulations, there could be jet stream, there could be trade winds, there could be polar jets. You have geostrophic winds, you have thermal winds, you have gradient winds, you have topographic winds, windstorms, land breeze, sea breeze, downdraft, typhoon, tornado. So there are, by the nature, different kinds of things you have. So that's kind of allows you to have different types of wind also, wind types. So if you look at the wind energy, this is a picture from a 1.5 megawatt turbine in Texas, US. So just shows that the structure of the size, and you see the people sitting there for the maintenance work or some kind of an work. So wind turbines operate on a simple principle. So the energy in the wind, it turns these blades, which are having some kind of a aerofoil shape and all these things, and turns around a rotor. Rotors and all these things sit here in this particular. We'll see that what are those things. The rotor is connected to the main shaft, which spins and generates to create electricity. So it's a simple, you have a mechanical motion which is turning and generating the electricity. That's what it is. So wind turbines are mounted on a tower to capture most of the energy. So if you have certain height, then this could be above the ground. That could be advantageous. Faster and less turbulent wind, which would allow you to. Also, wind turbine can be used to produce for some home and building. They can be connected to a grid or more widespread electricity distribution. So depends on the kind of that. So now, if we look at the some of the advantages of the wind energy, it's a clean and renewable source of power. So that is one of the advantage. This is cost effective because you are using wind as a natural fuel. You have rapid growth of industry and large potential because a lot of private partners, public partners, they are collaborating or having their joint venture. But yes, as we know, there is nothing comes at free. So there is a cost to pay. Is that wind reliability? That means to use wind energy or generating power through wind, important resource or important key gradient is that the reliability of the wind. That means throughout the year we should have a sustained wind speed and all this. And these are the things we'll talk about more and more as we move on the discussion, because why they are going to play an important roles and how this distribution may can vary. So there are places where you can have turbines installed, but maybe throughout the year you don't have the proper wind flow. So how that varies the production of the power and all these things. So wind reliability is important point, which includes a lot of other factors. So which may include that where are you going to install the turbine, whether the availability is there or not, throughout the year, what is the variation, throughout the month, how is the variation, throughout the week, how is the variation, throughout the day, how is the variation. So all these are going to be considered while somebody wants to install a turbine in a particular location or try to optimize that how much wind one can produce and things like that. Now, when you talk about this large horizontal axis wind turbine, there is always a threat to wildlife because it rotates along a bigger diameter. So anything, any birds, environmental things, there would be some issues because if they are within this domain, then there is a chance of having hit with the turbine blades and all this. Obviously, some noise and visual pollutions are also there. Okay. Now, what are the key components of these wind turbines? Yes, this is horizontal axis wind turbine because we'll later talk about vertical axis wind turbine as well. But this picture is all horizontal axis wind turbine. So you need one foundation above which the things are going to be. Then you need a tower. So this is the tower. Okay. We'll come to that in the next picture where things will be much more clearer. You need rotor, which is housed here. You need nacelle, gearbox. You need high-speed shaft. You need generator, control system, yaw mechanism. Yaw mechanism is going to actually change the motion of the blades and things like that. Um, so, I mean, this is the tower and you have a blade. Then you try to, depending on the width, you should be able to move like that. So those kind of mechanisms also need to be installed there. Here is the picture of a GE wind turbine. These are your blades. This is where your rotor. This is your pitch system, yaw drive, tower, controller, generator, and all this. So yaw is a twisting or oscillation motion of the moving ship or aircraft around the vertical axis. So this is what, if we talk about the wind turbine, as I said, if the air is coming from this side perpendicular to the this thing, so this is called the yaw motion. So depending on the wind coming from this side, the blade should be aligned to some extent. Pitching is that this is the horizontal axis, around that the pitching happens. So obviously you can make little bit of adjustment to the blades so that. So these are some of the key components of the turbine, horizontal axis wind turbine, and their mechanism drive which is sitting. So you can see the base is the foundation, and the base at the bottom, top of which the tower is there. And then you have, so typical turbine characteristics that one can think about. The rotor diameter is up to 120 meter. Half height is one up to one, so up to 6 megawatt now, but 15 megawatt offshore, which is essentially this 15 megawatt is an latest NREL US National Renewable Energy Laboratory, their design, which has been tested. Typical cut-in wind speed will be 3 to 4 meter per second. Rated wind speed could be 15 meter per second. Cut-off wind speed typically 25 meter per second, and things like that. Now it depends where we install these turbines. So onshore, typically 2 megawatts, some are up to 4 megawatt, but restricted due to the logistical difficulties of transporting blades by road. So onshore output capacity is not very high compared to the offshore output capacity, which is quite high, where the turbines are available, largest can be available, and you can install there because it's on the onshore, so you don't have the other hazards like land, transportation, wildlife, noise, pollution, things like that. Oh, that is one of the advantages. So as of today, your offshore production capacity is quite higher. I mean, 3 to 4 or 5 times magnitude higher than the onshore capacity across the world. Also, that can lead to some other challenges, like building larger turbine for offshore is as one of the keys to reducing the still high unit cost of offshore wind energy. So not only that, the installation of the offshore turbine kind of poses a different kind of challenges. So that's another thing that one can think about. Now, again, coming back to this particular picture, where you can see as we have increased the production capacity, how the turbine size has gone up. You can see this is 126 meters. Typical Airbus 380, which is one of the largest aircraft, the wingspan is 80 meter. Now you think about 126 meter, how big is this? So that means to install it, and now this is going to be more higher for 15 megawatt turbine. So this kind of large scale turbine, as we say that power is always increases with the area. So if our area is higher, then you can have larger turbine for producing capacity. But at the same time, handling maintenance of this kind of large size turbines are not very easy. Because this gives you an idea when you compare with the Airbus 380, and that's such a big aircraft. It cannot be kind of landed in every airport across the world. There are specific airports where they can actually allow that landing of that big aircraft. And you talk about 5 megawatt, where that 126-meter turbine blade is such a big one. And 15 megawatt, this is quite higher than that. Okay. Now, similarly, if you look at the trends in the onshore wind rotor diameter and turbine size, and this is the distributions at different country wise. So this is how the year wise that has spanned. This data is from the old data just to give you an idea how this trend is varying across the country and how that is changing with the diameters and all these things. So now expected growth in offshore turbine size globally. So you can see very interestingly the cruise ship, which is 45 meter. We have 1.6 megawatt, which is height is rotor diameter is 69 meter. 3 megawatt rotor diameter 90 meter. 2.9 94 meter. 4.1 119. 11 megawatt 190. This is what we expect by 2030 as we. So this is again, we're talking about, and this is specific power and the trend or the increasing trend with the size, that is obviously these are offshore turbine. So more and more power generation capacity has been established. You need a larger swept area of the turbine. So more larger swept area, obviously that can pose different challenges. It poses challenges of the design, optimization. Optimization includes everything, not only optimizations about the turbine performance and all these things. Optimizations also, one can think about the logistical optimizations, that the geometrical locations, transportation of the electricity to the grid or nearby places. So everything should include in this optimization process. It's not only the design optimization process that I mean. Then design optimization, then installation, then you have these things, what you call transportation, then power transmission or power distribution. So where you produce, you might need to transmit that produced electricity to the nearby places or some grid. Then from there you will try to distribute. Obviously, later on when we talk about the turbine technology, you can see that what wind turbines, what kind of current or electricity it produces and what we use at the household level. Our daily use, we use alternative current, but turbine produces direct current. So these are all these different kind of factors that one has to. So more and more larger increase in the size. Yes, you can produce more power, but at the same time, one has to keep in mind that there are the other challenges as an engineer you are going to face. How am I going to design this? How am I going to manufacture? Yeah, one important factor is that design optimization and manufacturing. So how am I going to manufacture this? And all these things you have to install as a system level integration where you need to connect that, okay, how am I going to transmit my electricity from there to grid or the nearby usable places and things like that. So these are the challenges, the key challenges that you have while you are increasing your size. At the same time, it is also true we need to increase the size to increase our or production capacity or energy harnessing capacity. Okay, we'll continue this discussion in the other session. So we'll stop here and continue from there in the other session. Thank you.